right, let's talk about REST APIs. I know it's been a bit of a crazy couple of weeks, but I'm hoping you're starting to get kind of into some kind of rhythm with the new arrangement that we've got. So, a couple changes that I've made. One is I've put together some notes in the form of Google slideshow so that if after watching, my lecture or whatever, you want to kind of go back and just see notes that I took as part of that process, you'll have access to them. So in the module, there's a link to this presentation that I'm showing you. And hopefully between that and the video, that'll get you over the hump. Definitely, if you have some questions and you want to follow up on something, contact me. Got a bunch of ways to do that. So, just take the bull by the horns and let's get this thing figured out. So, what we're talking about this week, I guess we're in week 10 now, is REST APIs. So, I guess I would say pretty typical computer science fashion, we have two acronyms, and one of them is semi-meaningful, the other one maybe not so much. So I want to unpack those a little bit so that we establish context for what we're trying to accomplish. Remember, an API is an application programming interface. The whole point of an API is that we want to have a way for us to connect with an existing tool or application or something through control of a program rather than us doing it ourselves. So, for example, if I'm using Canvas, I can log into Canvas through a web browser and I can click on things and make things happen in Canvas, and that's great. That's a web interface. Canvas also has an API interface, and that interface, I essentially send commands or requests for information, whatever, to Canvas, and it'll respond. And so those commands are things that I can send from a program. And so essentially my program can connect to Canvas. It can interact with Canvas in some way. It can pull information down. It can cause an action to occur in Canvas and so on. And it's done through the API, the Application Programming Interface. It's an interface between an application and a program. Okay, so REST stands for Representational State Transfer. Some things about REST. REST is technically an architectural style. It is not a particular protocol or a particular language or whatever. Now, in what I will call modern times, pretty much anybody who uses a REST API or talks about a REST API, they almost always mean that it's in the context of HTTP, which is the protocol that runs the web. And for that reason, REST APIs have become very common. I have here 6 guiding constraints for REST APIs. I'm going to briefly talk about these. It is unlikely that these would find themselves on an exam at some point, but it's useful as background for what, this representational state transfer, what that means. The architectural style of REST assumes a client-server architecture. And again, if you think of the prime example of where REST is used in HTTP, the web is a client-server architecture. You have servers who are always on and handling requests, and clients who make connections to the server with various requests, either to do something for them or to return information. REST assumes that there's stateless communication, meaning that when you make your request, you're bringing with that request everything you need in order for that request to be satisfied. And there's no memory that you made another request earlier. It's a little bit like, with these, the latest, Alexa apps or whatever. It is not very conversational at all. If you want to, have a communication with one of those devices, you have to say the wake up word, then you have to say, some very specific kind of thing. And if, if that didn't go well, you can't just add one more thing to what you wanted to say or try that thing again. You have to go back, redo the wake up word, and then, so on. And so in that sense, it's like stateless communication. There's nothing about your previous request that was remembered when you make your next request. Um, the REST architecture should be cacheable, and again, that's a pretty common concept in the web. We also have the ability to say don't cache this or don't remember it, but lots of things are cacheable. The idea of a layered system approach is that a particular REST uh, architecture might be in the middle of a whole series of things. So, we don't know if we're like the end all be all, if we're just one piece of the puzzle and we're, going to, this location to get information, and that may, be layered in some complicated way. It provides a uniform interface. We have some pretty common verbs or methods, as they're called sometimes, that we will use in that communication. And the other guiding principles allows code to be passed. That's getting well, yeah, it allows code to be passed. So I think that's all I want to say about the theory background kind of stuff related to REST. So nowadays, when we talk about REST, we are almost always talking about the HTTP protocol. And we're usually talking about 4, sometimes 5 methods. The 4 methods or actions or verbs that we use most often are get, post, put, and delete. And we've been using get and post all semester long in the context of web. We maybe haven't really encountered put and delete as HTTP actions, although those are available. Another one, the one that I would call the 5th most common, might be called patch. And generally speaking, I'd say a lot of folks, when they're designing their API, they'll actually use put instead of patch because they're kind of similar. Anyway, these are the 4 that we're going to focus on. When we write our own APIs, we're going to say, okay, we're going to allow get request, we're going to allow post request, put request, and delete request. Post means create or add new info. So a post request would be if I want to create a new entry, I'm going to do that. A put request is a request to modify a value. So it already exists. We just want to change it in some way. And delete, of course, removes info, and get is requesting or retrieving information. Anytime you make a request in HTTP, the HTTP response header, it comes back with a header, and one of the things in the header is the status code. If you want a full list of status codes, then I would encourage you to consult the source of all true wisdom and knowledge, which is, of course, Wikipedia. And I've got a link here if you want the full list. Some pretty common ones are these. Wouldn't kill you to memorize these. It's just kind of helpful to have these kind of stored away in your head. 200 means okay, it was successful. 201 is an object was created. So if you make a post request to create an object and it works, then 201 would be the expected status code. 204 means no content. Sometimes that will be returned for a successful delete, for example. The 200 codes all mean success or okay or good in some way. 400 requests in the 400 range usually indicate some kind of not great situation. Something wasn't right about the request. It could be a bad request because the request was malformed. It could be it was a well-formed request, but the user authentication that was passed along with it, the user is not authorized. And by not authorized, I mean not logged in, okay? Or it could be forbidden. It might be a logged in user, but they try to do something that a user with their credentials isn't allowed to do. That would give you a 403 forbidden. Most people are pretty familiar with the 404, not found. So if you're requesting something and the server's like, I don't know what it is you want. Um, if you get 500 error messages, these usually aren't great. It means there is some kind of error. And a 500 in particular means internal server error. If you make an API request and you get an internal server error, there's something wrong with the server. In theory, you shouldn't be able to make some request to the server and then it causes the server to crash, because that's essentially what that means. However, it's not that uncommon to be able to get these internal server errors. And you've written enough code to realize that you can have a whole bunch of cases covered, and the one case that you don't have covered is the one that a bunch of users are going to find. 503, service unavailable, would imply uh, something that's normally would have been an okay request, but on the server it's not running. So for example, if the database was down, we would expect a service unavailable response code. So those are just a quick overview of response codes that are available. Okay, so enough talking about it. I want to look at some simple uh, REST API examples. And I think it would be totally appropriate for us to use the Star Wars API, or SWAPI for short. The Star Wars API is a fun little API that will allow you to extract all kinds of information about the Star Wars universe. And for example, if you wanted to see a list of um, 10 planets, the first 10 planets in the database, you would do you would say get https swappy.co/API/planets. That'll give you the first 10 planets in the list. Down here, I showed an example for any of these requests that you do. If you want to see like the next 10, you can do $page equals, and then you give the page number, and it'll pull in, that next set of results. That's just how this particular API works. If you want to see information about a particular entry, you can do whatever the category is, slash, and then the ID number of the element. So if you said, I want to see people /36, that would give you everything they have in the database on Jar Jar Binks, which I know is your favorite character. Okay, so here we have, this request right here. If we do this GET request, the response would look like this. What I want you to see is that the response is actually in JSON. Not 100% true. This particular API, it'll return a web version of the response, or you can say, I want it to be a JSON response, or you can actually either have a Wookiee response, which I haven't really played around with, but I'm pretty sure all of you, having heard that, are going to immediately run out and say, okay, let's play with the Wookiee response and see what we get here. See, I knew I could convince you to come play with this API a little bit. So how do you issue a GET request to this API? Well, one way, of course, is to simply use a browser. So I could open my browser. Let me come here, and let's go ahead and go to this swampy.co/API/people/36. It's actually giving me the default reply, which is a web. That's why I built a web page when I did that request. If I switch my GET request to be JSON format, notice here it comes back with just plain JSON text. And there is my result. Here's everything we need to know about Jar Jar Binks. You might be fascinated to learn that his mass is 66 units. And we aren't exactly sure. I guess we would need to go find a human and find out, might be able to estimate, how much different ones weigh. Anyway, that's an example of issuing a GET request. And that kind of brings us to this question of, so how can we interact with an existing REST API? I mean, if somebody has an API out there and we want to interact with it, certainly we can use a browser like we just did. The advantage of that is the browser is obviously very readily available. It's very convenient. If you want to do a simple GET request, you literally type the endpoint in the browser and it will, spit back the result and show it to you on the screen. Very handy. You can also interact with the REST API through command line. When you're doing it from the command line, you can actually do a variety of requests. If you wanted to issue, for example, a post request in a browser, you actually have to build your own web page that does the post request, click on the button and so on. That's a real pain. And when you're going to do that in the command line, you can actually just, type a couple extra things and now it's a post request or whatever. A third way, but one thing I'll say, the downside of a command line, while it's very flexible, it does take time to learn the syntax and the options and so on. Another way to interact with an API is to use a dedicated REST API tool. If it's a dedicated tool for that purpose, it's going to give you a lot of flexibility. It's going to have a less steep learning curve than the command line. And it will have some good options for different forms of authentication. So we're actually going to look at one such tool today, and you'll be using that to test your own API that you are going to do later. Another way, of course, to interact with a REST API, because remember, it is an application programming interface. You can write a program to interface with the application, and obviously we're going to be very interested in doing that. So in this particular course, we're going to do two things. We're first going to create our own API. That is, we saw an example of the Star Wars API that somebody else created, and they take the endpoint that you request, and they'll, do whatever. That particular API, all you can do with it is GET request. You can just pull information from it. You can't, add new information to their database and so on. Well, we want the ability to, do a variety of requests. So we're going to create our own API. And then once we've created that API and we have it stable and it's all working great, we're going to use that API we created as a piece of our web application. So the idea is right now our web application kind of when we get a request from the user, we go straight to the database and whatever. Instead of going to the database, we're going to go to our API. And so our API is going to be this interface between the database and our application. One thing that may not be obvious to you right now is, so like, why would we put this kind of extra layer in our web application? It's complicated enough as it is. Well, think of it this way. Let's suppose that you wanted to have an application that you wanted people to be able to go to a web page to interact with your application. You wanted them to be able to use a native app in the Android environment and in the iOS environment, and you might want you know even people to write their own programs to be able to create their own front end to your particular application. Well, if you write an API for the back end to handle those requests, then all those different front ends can use the exact same API. So you write your back end code once, you make it rock solid, and then anybody who wants to write a front end will interact with the user and whatever, but they'll send their request to your API, and that API will work for everyone, and it will be very consistent. So that's one of the big benefits of this kind of API approach. And we'll be seeing how that works this semester in the assignments that we're getting ready to jump into. So I want to spend a minute to talk about interacting with an API from the command line. This is just a useful skill that really I think any computerish kind of person ought to know. We're going to use a command line tool called curl. Curl is pretty widely installed. It's installed by default. Like if you do git bash in a Windows environment, it'll be there. It'll be there if you go to Mac OS at the command line. If you go to any Linux command line, almost always this curl command will be installed. And so we're going to look at some examples real quick. The basic usage is you say curl, and then you give the endpoint that you want to get the result from. So in this case, I'm going to go to our Star Wars API, find out who person number one is, and get that result formatted as a JSON value. Some other options that you can, so you can do curl minus v. It'll show you in detail what curl's sending with the request. You can redirect its output to a file using this, and so on and so forth. So these are some pretty useful things that you might find handy as you move forward. Okay, we aren't ready to do that yet. Let's do some examples of curl from the command line. So we're gonna go to this API here and see what we get. What I'm gonna do is I'm actually gonna, here I've got a window open to the CSCI server, and we're just gonna play around with that. So curl HTTPS swappy swap Star Wars API .co API /people/1 question mark format equal JSON. Okay, I think that's what that string said. Okay, good, that worked. All right, so turns out that the person whose ID is 1 is Luke Skywalker. His mass is 77. Jar Jar Binks to me looked like he was I don't know, probably 7 feet tall compared to other people. I can't believe that his mass is only 66. Maybe he, is not very dense. Um, I don't know. We'll have to investigate that. I think we're going to have to call into question some of these statistics here, and that is totally the point of what we're doing. So here we go. Yeah, we got our JSON response, and yeah, that looks pretty good. So that was an example of me using curl to get something. Hopefully, you're thinking to yourself, okay, it's great that we got this JSON response, but boy, that's really hard to read. That's why I was going to tell you about a little tool called JQ. JQ is not as often installed as curl is, so if you're working on a particular system and JQ isn't installed, you may have to look up how to get it installed in that environment. There's lots of good instructions out there, so it's not that wild or different. But this JQ command is a command line JSON processor, and it will kind of help format some stuff. The basic usage, like if you're using it with curl, you would basically do the curl command, which returns your JSON string, and then you would pipe it to this JQ command, which will be the formatter. And then in single quotes, you apply some filter. If you just put a period in the filter, that's the so-called identity filter, which basically says, just keep the full JSON string like it came. Later, we'll play around with some filters that, produce different formats. So if I come back here to my command line, let me get back here. And I'm going to do the same request, but this time I'm going to pipe it to JQ, and I'm going to pass it through the identity filter. And I do it. This result, suddenly it looks so much nicer and more readable. This stuff right here that showed up, that is just some connection stats that curl likes to show sometimes. If you don't want that to happen, you can do curl -s to make that silent. And we can do that same request. Now notice we get the result without all the stats up at the front. This is so much more readable. If we were going to get a list of people, we could do that. And notice it scrolled all the way to the bottom. I think, well, anyway, if we're going to pipe it to less, I think we have to, well, here. I don't think this is in the notes, but let's just play around with that. Yeah, if we pipe it to less, we lost that formatting. It seems like there's a -r or something like that you could apply to, I don't know, we'll have to Google that to see how to get the colors back if you pipe it to less. But if you pipe it to less, basically it'll give you the list, and you can just hit spacebar or page up, page down to cycle through the results. Cue to quit. So that's just FYI. But again, still nicely formatted and much more readable. All right, so where are we on this? Oh, wrong browser. Oh, I was going to show you that you can also apply other filters. If we come back to the one where we got the list, um, there's the whole list of people. What I want you to see is we got a JSON object that has account, next, previous, and results. Results is an array, okay? So all the interesting stuff is in the attribute results name is results, which is an array, and it's an array of objects. So, if I wanted to see, well, what are just the names of the people on this list? Well, I could apply my filter, and I can say, okay, I need to go to results. So my filter is go to the results object. That results is an array. And I'm in particular interested in the name attribute of that. And I don't think we need this here anymore. So I do that. Now notice it still gave me the results, but this time it filtered the JSON to have just the name portion of these elements. And so I can see who these folks are. Um, They're a pretty useful tutorial if you want to like fool around with JQ and kind of say, okay, what other options are there? How else can I format? If you're going to get pretty serious about using curl from the command line, you will definitely want to investigate JQ. Okay, wanted to say a few things about REST authentication. Right now when we're interacting with this Star Wars API, it's strictly in a GET basis, and they have it wide open to anybody who wants to, so there's no authentication needed and whatever. Obviously, for a lot of APIs, you're going to have some form of user authentication. There's a bunch of ways it could be done. A couple that are pretty common. One is called basic auth. It's a little bit older. More often now, you'll see the bearer token auth. And, one example of a bearer token would be the Canvas API. I'm going to demonstrate this real quickly. I hope it's quickly. Oops. Okay. So I'm going to come to Canvas. You can do this too in your Canvas account. So if you're ever wondering, like, how can I interact with the Canvas API? Well, now this is your chance. So if you go to Account Settings, and from there, scroll down, and I'm in a section here, Approved Integrations. You can create your own access token. Just click on New Access Token Purpose. This is for a demo. I'm going to set an expiration date just in case I forget that I put that out there, because you're going to see my beautiful token. And then I can click Generate Token. It'll show you the token that got generated by that particular request. This token, you have to copy it down and you need to put it in a safe place, because after this screen goes away, you're not going to be able to see this token again. Okay, so you don't get to look at it. They generate it, they show it to you, and then forevermore, you're not allowed to access it. So I'm going to copy that and close that. Okay, so now I'm ready to do a request. If you're going to use this token, bearer token, what you have to do is add a header to the HTTP request, and the header has this form: the word authorization, colon, the word bearer with a capital B, space, and then whatever the long token is that is going to be used to identify yourself. That token I just copied, that's my long token. So if I wanted to pull something from, like, for example, see a list of my courses, we'll do this in a few steps. Then I would go to hsutx.instructure.com. That's the site for Canvas /API/v1 for version 1. And then I want to see my courses. So let's come back here to CSCI, and I'll say curl https hsutx instructure.com /API/version1/courses. Let's start with that. Notice that request, it was valid in one sense, but it came back with the status unauthenticated. That's because they're saying, look, you don't have permission to see just courses. So I'm going to have to put a header in here. So it's a minus capital H. And then in quotes, I put whatever header I want to have. So what I'm going to do here is it's authorization bearer. And then I'm going to paste in my token. And I think that might be right. Oh, wow. Okay, that's great. Notice it came back with a big old list of junk here. That was actually a valid request. So I'm going to do a couple things. One is I'm going to format this using JQ, and we'll just do our standard. So here we go. Here it is. Here's all the courses that I have. I'm looking at this and I say, okay, there's the name of my courses. Um, oops, I was trying to get to the top of my request here. Okay, so it's an array of objects. I want to get the name from it. Okay, so I'm going to say it's an array of objects and I want the name element of my object. So there is my list of courses that I have. You'll notice these are from 17 fall and 18 fall. That's pretty old. Oh, it's showing me the first ones that it came up with. And let's see, those courses are, oh, it's only showing 10. Let's see, the Canvas API, uh, you can add a question mark per page, and then you can say what the maximum number you want on a page is. I'll say 1,000, that should cover me. Okay, here's my full list of courses that I have in Canvas. Okay, and again, I'm getting that straight from Canvas. The Canvas API has, once I'm authenticated as me with the proper token, I can write stuff that I'm allowed to write to in Canvas. I can read stuff that I want from Canvas, and I can do it all from the command line like this, or from control of a program. Uh, kind of cool. All right, that's enough of that. Okay, while I'm thinking of it, and I'd say, if you're just fooling around with um, stuff like I just did, and you kind of realize, okay, I think I'm finished with that, you can come down here. Here's the token that I had just created. I'm going to go ahead and delete that, even though it's expiring in a day. And that way, that token won't be useful. In fact, if I came down here and reissued that request, it wouldn't work now. Okay, so that's all I'm going to say about REST authentication. When you write your own REST API, you're going to use this bearer token concept. All right. I do want to show you a program called Postman. Postman is a dedicated API client tool, and it's a pretty good one. Lots of people use it and like it. I've got a link here for downloading it. I've already downloaded it, so I'm just gonna, there's Postman. I'm going to run the application. And it seems to be taking its sweet time. I'm going to pause this until it, oh, wait, no, here it comes. All right, yeah, there's the usual startup routine. I guess it's still taking its sweet time. Still taking its sweet time. There we go. All right, when it starts up, I'm going to just show you a couple things that'll hopefully get you started soon. When you first start up, it's going to have this kind of login screen. It's like, oh, please sign up, please sign up. It's okay for you to sign up if you want to, but you do not have to do that. Um, I, if you just close that screen where they're asking you to sign in, it'll pull you up to a screen that looks like this. First thing you kind of need to do is create a collection. The idea is you might be interacting with a variety of different APIs. So if I were doing this and say, oh yeah, this is the collection of requests I'm going to create for the Swappy API. So if you click here and then let's see, from this you can say add request. So you can add a request to this, And you can give it some kind of a nickname. This is get people. So we will save that request. So, all right. Uh, so there's my get people request right here. See, I've got a bunch of tabs open. I guess that's from other stuff that I did earlier. All right, here's my get people request. So we'll go back to the SWAPI API. I'm gonna do a get request, by the way. If you want to do a different uh, action, you can do that. You can see there's a bunch of options there, but I'm gonna do a get of swapi.co slash people slash API slash people, and let's send the request. All right. This gives you lots of information that wasn't immediately available from curl. You can get it from curl, but you're going to have to do the verbose option and some other stuff to kind of do it. But notice it gives you all kinds of great information. Status code, how long the request took. I can see information about the request that I sent and about the response that I got back. Here's the response body that has all the stuff. And notice it recognized it as JSON and it formatted it nice and pretty for me without me having to do some extra work. If it doesn't recognize it quite right, you can always change what format you want to see it in. They do not, however, have an option for Wookiee, so keep that in mind. Okay, so Postman, you're going to be using it a good bit to test your own API. It is a really convenient tool because the idea is when you're building the API, you don't have to create web pages to do post requests and put requests. You just want to be able to say, oh, I want to do a put request. I want it to go to this particular endpoint. I'm going to set these things in the body, and I'm going to form URL encoded, and here's the values that I'm going to send and so on. I demonstrate all that in the lab day video, so just know that that's coming. Okay, I think that brings us to the end of our notes and mercifully to the end of what I wanted to say about working with REST APIs. What you're going to be doing moving forward is we're going to use Laravel for you to create your own API. The application will accept HTTP requests to specific endpoints. You already kind of know that concept because you know how to define routes. We're just going to define routes for API instead of web. So it'll be route/api.php. And we're going to make a few changes in the application itself so that it's kind of optimized for working with an API. If we had all the time in the world, I would probably use a slightly different tool that's very similar to Laravel, same folks who wrote it, but it is specifically for creating APIs, and so it doesn't require some of the other fiddling around. But to me, it was like, okay, we're already learning enough kind of new environments and tools and whatever. So I felt like it was good to stay with Laravel for this one. When those requests come in, you're gonna validate those requests, and next week we'll actually come through and authenticate those requests, and we're gonna return JSON responses with appropriate status code. I think at this point, if you want to jump in and start on the video for Lab 10, I think you're going to be good. Let me know what you need.